She got close.
All right, here we go, guys. I turned back some stuff. Here we go. We will be having another quiz soon. Is it?
Yep, I got you.
We'll be having another quiz soon. We'll practice for it tomorrow, so then it'll be the next class after that. That is up to be. Okay, well, whatever. And then, we'll be ready for a test, because we're almost done with the chapter, so we'll be having another test. Soon, start practicing.
We'll have it before March 6th.
Yes.
Okay, Ms. Smart, I can do a quiz. I can do a quiz and a test.
Okay.
Barely make it now.
All right, here we go. We're in our 5.6 notes. We're on the back of page 42, ready for problem 2. And now we're kind of switching gears a little bit. Instead of finding sides and angles, we are going to find the area of the triangles. Now, when I say that to you, find the area of the triangle, what pops into your head? Something should pop in. What? 1/2 base times height? Sure, that's the formula that you used before. Great formula. What is wrong with the formula though? Why is it not very useful, especially in a problem like this? We don't know the height. Now, could we find the height? Yes, but that would be kind of complicated and take a lot of extra steps. Luckily for us, there is a short, sweet, easy way of finding the area if we know all 3 sides, okay? The formula, and you'll want to write this down maybe at the top of the page or something, and then I'm going to tell you what all this means. Because you're going to look at this formula and say, you said it was easy. That looks hard. Well, no, it's very, very easy. This is actually called Hero's formula, after Heron of Alexandria. Hero's formula. And it finds the area of a triangle if you know all 3 sides. Okay. Any guesses what the A, lowercase a, B, and C stand for in the formula? The sides of the triangle, right? So this is side A, this is side C, this is side B. So what is this S? S is the semi-perimeter. What is the perimeter of this triangle? The actual perimeter. What is the actual perimeter? 38. So the semi-perimeter is half of that, like a semicircle, half a circle. So we're going to have 19. Now, 19 minus A. So 19 minus A would be 7. 19 minus B, which would be 3. And 19 minus C, which is 9. So we just multiply all those numbers together and square root it. And the area of this guy is 59.92. Is that what you got? Come on, type it in with me. Let's go. Where did all these numbers come from? The first one is the actual side perimeter. And then where did we get these three numbers? We took 19 minus each side. That's it. Let's skip to D, because it's the same thing. So your job is to find the area of this triangle. So what is the first thing you're gonna do? Notice you have all three sides. What's the first thing you're gonna do? Add them all up, find the perimeter. So what is the perimeter? 43. Everybody okay with that? Now, 43 does not go into your formula though. Your formula calls for half of that. So 21.5. And then there's three more numbers you're gonna times by. And how are you gonna get those three numbers? You're gonna take 21.5 minus each of those. Does the order matter, do you think? No. So 21.5 minus 17, 4.5. 21.5 minus 11, and 21.5 minus 15. Did I do my subtraction right, I hope? And then we just multiply them all together. Wasn't that zero guys smart to figure this out? I got 81.26.
Yep.
All right, so one more time, because we're moving on to a different kind of problem now. If we know all three sides, we can find area by finding the perimeter and cutting it in half. Then taking that number minus each side, multiplying it all together and taking the square root. Easy? So this formula though is only appropriate if you know all three sides, because you have to know the perimeter, so you need to know all three sides. So let's go back to question B now. We do not know all three sides. So we will not be using Hero's formula. Luckily for us, there is an equally simple, maybe even more simple, way of finding the area when we know two sides and the angle in between them. Bo, are you sick?
What? No, I'm all good.
Okay,
I was
well then sit
saying
up
a
in your
little prayer,
chair.
talking to Jesus.
Okay, sit up in your chair. Yeah. Ask Jesus to get you through pre-cal.
My bad.
Okay, all right. The area, very, very simple. When you know two sides and the angle in between them. Now that's important. Two sides and the angle in between them. Area will be always 1/2 times side times side times sine of included angle. So this is called the included angle. It's included between the two sides. So there's really no work to do. I just take 1/2 times 12 times 10 times sine 58. That's all there is to it, you guys. You don't have to do any work. 1/2 times 12 times 10 times sine 58. And that area is 50.88. Wow. It just doesn't get any easier than that. Could I do the same thing with problem C? Yeah, because what do I have in problem C? I have two sides and the angle in between them. Do you see that? This is like the best case ever. Two sides and the angle in between them. So what does my formula say? The area is 1/2 16 times 15 times sine 84. 1/2 side, side, sine. Wow. I got 119.34. You okay with that? So, if we have all three sides, we're going to do Hero's formula. That's the big radical. If we have two sides and the angle in between, we're just jumping in and doing 1/2 side, side, side. The interesting part comes with the next problem. Do you notice in the next problem that we do not have all three sides, and we don't have two sides in the included angle? Did you notice that? Any thoughts on how we're going to find the area of this triangle in problem E? If I had this side right here, for example, I'll call it side B. If I had side B, could I find the area of the triangle? Absolutely. The area of the triangle would be 1/2 16 B sine 62. Would everybody agree with that? If I knew this number, it'd be 1/2 that, sine that. Okay, think about the quiz you just took. Can you find that side? I think you can, because you have a 62 and a 49. So what's that gonna make this one?
69.
Is that 69?
Yeah.
Double check that. Okay. And then look what you got right here. What does that mean? When you have that kind of information, what does that mean? Law of sines. So I could do sine 69 over 16 equals sine 49 over B. Now again, why am I doing that? Because in order to find the area, I have to know that side. So I'm going to do my law of sines. B sine 69 equals 16 sine 49. Divide by sine 69. So I have 16 sine 49 over sine 69. Right, are you keeping up? That's what you just did on your quiz, law of sines. Now I'll type that in. 16 sine 49 divided by sine 60. Did you get like 12.93? So side B, this is what I was looking for. now I know it's 12.93. And now I can find my area. Did you get 91.33?
Yep.
So, best case scenario is 2 sides and the angle in between. Or all 3 sides. Both of those are really easy problems. If you don't have that, then you're gonna have to do your lost signs to get what you need so that you can find the area. Okay? Ooh, now we got a few word problems. Here we go. Find the area of a regular hexagon inscribed in a circle with a radius of 22 feet. Oh my gosh, what does that even mean? Anybody know what this means? What's a hexagon? 6 sides. What does regular mean? When it says it's a regular hexagon. All the sides and angles are congruent. What does inscribed in a circle mean? So I'm going to draw a circle, okay? You go ahead and draw a circle too. No one's grading your picture, but I'm going to show you the easiest way to draw a picture of this. Draw a circle. Okay, put 6 marks as evenly spaced as you can around the circle. Now connect those marks with lines. And you will have kind of a regular hexagon inscribed in a circle. Now we know the radius of the circle is 22. Could I draw in more radii? Could I, in fact, draw in all the 6 radii like that? And wouldn't they all be 22? And all the way around this center here, all the way around there would be 360. Would you agree?
Mm-hmm.
But I split that 360 up into 1, 2, 3, 4, 5, 6 pieces. So this angle right here is 60. 60, 60, all these are 60. Because there's 6 of them, and they add up to 360. Now let's look at this triangle right here, guys, just the triangle. Can I find the area of that triangle? Really easily. The area of the triangle is 1/2 side times side times sine of included angle. Remember that? That is our handy dandy area formula. 1/2 side sine. 22, 22 sine 60. Now that's the area of the triangle. How will I then find the area of the hexagon? Take that times 6. Aren't there 6 of those guys around there? Easy peasy. Here we go. Triangle. 1/2 times 22 times 22 times sine 60. And then just hit times 6. Don't round it off. Just hit times 6. did you get 1257.47 square feet? When you get your triangle, don't round it off, just hit times 6, and this is what you should get. Does that look okay? Let's bump down to number 4 and do exactly the same thing. But what's different about problem number 4? It's a pentagon, which means 5 sides. So 1, 2, 3, 4, 5 marks around my circle. Nobody's grading your picture, so don't worry about it if it looks a little weird. There's your pentagon. And the radius is 28 inches. I'm on problem number 4. So I'm going to go ahead and draw in all my triangles. You don't have to do that, but you can. And all of the radii that you draw in will be 28. And you should have 5 congruent triangles. Now, the key is I need this angle right here. So what do I know about all the way around that center? I know all of these have to add up to 360, but there's 5 of them. So this time it's 72. Can I find the area of my triangle? So easy. The area of the triangle is what? 1/2, 28, 28, sine 72. Area is 1/2. Side, side, sine. Side, side, sine. Now I can type that in. That will not be the answer though. That is the triangle area. So to get the whole pentagon, I have to take that triangle area times 5. So the area of the pentagon is 1864.07 square inches.
How do you get this?
360 divided by 5. Huh? Yours says what? Oh. I'm problem number 4. We're doing 4. We're doing the pentagon problem. Now, I promise on test day, you're gonna get a question just like this. It might be a decagon. Okay, what's different about a decagon? 10 sides, which means 10 triangles, which means central angle is 360 divided by 10 or 36. You can have any kind of regular polygon and do the problem exactly the same way. Okay? All right, so guaranteed a question like that. Now, let's see about number 2. Number 2 is not a polygon inscribed in a circle. Number 2 is a parallelogram. Okay, anybody remember what a parallelogram looks like?
4 sides. Is there 4 equal sides?
No, the sides aren't necessarily equal. They would be in a rhombus, but not in a regular parallelogram. A parallelogram, in general, is like a rectangle that you tilt over. This is a parallelogram. Got parallel sides, congruent, congruent. Find the area of a parallelogram whose sides measure 14 and 16. So this would also be 14 and this would also be 16. And the smaller angle, now when you look at your parallelogram, would you agree you've got a little angle and a big angle? The smaller one is 48. Find the area of the parallelogram. Any thought about that? How did I do my pentagon there a minute ago? I didn't find the area of the pentagon. I found the area of triangle first. So what if we split this into two triangles? Are those two triangles congruent to each other? So if I can find the area of this one, I'll just double it, and that will be my parallelogram. Now, look at this situation. Can I find the area of this triangle?
Yeah.
Just like that. The area of the triangle is 1/2, 14, 16, sine 48. 1/2 side, sine of included angle. Remember though, when you type that in, that is not the answer. You have to hit ×2. And the area of your parallelogram is 166.46 square centimeters. Anybody else get that?
Yeah.
Okay. All right, one more question. Let me redraw my parallelogram. Okay, there's my picture. For problem 3, I'm doing exactly the same parallelogram, but I'm not finding the area.
×2, right.
In problem 3, I am finding the length of the longer diagonal. Now, would you agree this pink thing is a diagonal? Is that the longer diagonal? Wouldn't this one be longer?
Yes.
So this is the diagonal I'm finding the length of. I'll call it X. Finding the length of that diagonal. Now, here's where things always mess us up if we're not thinking. When I draw in that diagonal, it does not bisect the angle. So don't think that that's 24 and that's 24. It is not. The diagonals of a parallelogram do not bisect the angles. The diagonals of a rhombus do, but this isn't a rhombus. So don't use that. Instead, we need to find this angle. Now that is easy if you remember your geometry. Does anybody remember the relationship? These are parallel lines. This is a transversal. These are consecutive interior angles. Does anybody remember the relationship between consecutive interior angles? Sometimes we call them same side interior angles. They are supplementary. And what does that mean? they add up to 180, always. So the minute you knew that one was 48, you automatically knew that one was 132. So if the little angle is 48, the big angle is 132, because they always add up to 180. Okay? Now, I want you to just look at this situation for a minute. I'm going to erase part of the problem that I don't need anymore. Your job is to find X. Not area, we're not doing area, we're doing find X. That's a law of sines or a law of cosines problem. If you need area, do area. But if you need a length or an angle, you need law of sines or cosines. So look at it. Is that going to be a law of sines problem or a law of cosines problem? It's got to be cosines, because I don't have this, I don't have this, and I don't have this. So this is going to be a law of cosines problem. Remember, with the law of cosines, cosine angle goes on this end. This is review from last week. And then what would go on this end all by itself, this little piece right here, would be x squared. Remember, whatever angle you got on this end, you have that side on this end. And then does anyone remember what goes in the middle here? What? 14 squared plus 16 squared minus 2, don't forget the minus 2 part, minus 2, 14, 16, cosine 132. So we can just type that in, easy enough to type in. Does anybody remember what we have to remember to do at the end though, after we get it all typed in? Square root it? And I got 27.42 centimeters. Okay. Let me hand out your practice test to you. Tomorrow, or I guess Thursday, we will do a practice quiz for area and the law of cosines.
This one, can you just square it in the problem?
Yep, square root. You get square root first, and then type in everything that will work.
It won't or will?
We're pretty good. Put yours away.
I want to put something in
So did everybody get a practice test? So tomorrow or Thursday,
When's 5.6 on Thursday, right?
5.6 is due on Thursday. Thanks for the reminder, Willow. 5.6.